Hi, my name's Sam Lanahan. I'm the inventor and founder of the C6XTY line of structural fabrics. Structural fabrics are derived from a synthetic lattice that I invented that can be made flexible, lightweight, and porous for a variety of applications. We're starting off with the evolution of synthetic lattices, and when we speak historically about the application of geometric principles to our lives, we realize that it's intimately intertwined with the materials themselves. So how has geometry been applied to everyday living? Well, we think about the circle becomes the wheel, and that's the very basis for transportation, which just transformed humanity. This is an ever-increasing attempt for man to clear broader spans with less weight. But the arch will only take you so far. And it wasn't really until strangely enough, the expansion of the railroads in the United States that we started to get into trussing systems. And so things they were able to use timber, which had a tremendous strength to weight ratio. And by triangulating the timber, we were able to achieve very high elevations to clear rivers and cross chasms, etc. But it was the materials themselves being triangulated that allowed all of that to take place. Synthetic lattices are based on the geometry of the fullerene, or the carbon-60 molecule. This discontinuous compression, continuous tension concept, the islands of compression in a sea of tension. These are Fuller's very words, and we can see that expressed in this, what I now call a structural fabric. Fuller introduces us to the geodesic dome. And the geodesic dome is supremely efficient for enclosing the most volume of the least surface area. Fuller demonstrated to us that these are supremely economical structures. Now I want to segue just for a moment and talk about Kenneth Snelson. Some of you are familiar with Kenneth Snelson. Kenneth Snelson deserves his rightful place as the progenitor of the network, but it's Fuller that really gave it language. Fuller describes it in his patent as a discontinuous continuous tension network. And it's Fuller that then continues to develop this as a theme and as a geometry. And you can see it throughout all of his literature. Certainly Synergetics is replete with all kinds of references to tensegrity. Tensegrity, of course, is a contraction of two words, tensile integrity. So my company, Flextegrity, is the contraction of two words, flexible integrity. So here we have discontinuous compression, continuous tension. So, and each one is isolated in a sea of tension. Synthetic lattices then deploy the geometry that Fuller elucidated with the geodesic dome. And I take the idea that forces are being transmitted around the surface of the sphere as if a ball bearing, and then collapse the compression column into this spherical shape. And then in a uniform ordered way, I am able to construct these synthetic lattices. But by changing the properties of the interconnecting element, I can make this relatively stiff so that it won't bend. So I have complete control over the plasticity of the material. I'm always excited and delighted when I connect with like minds and visionaries and people that get it. And that's what I've been struggling to do, is really connect with the right community, the right influencers who can take this and move it and give it a broader audience. So that's really been my incentive all along.
Is there an idea or a concept that you are curious to potentially collaborate with us, where our vision could help actually, make your objects come out?
I want to do your projects. right? I can do monumental scale public art. So if you have some complex geometry, some complex form that you want to make, I can get you there using these tools. We can build all of our bridges, we can build our infrastructure in such a manner that it's resilient in an earthquake and it's not going to collapse. This is how we want to build the next generation of resilient structures. Now that's all achievable with a synthetic lattice. And the closing line is Flextegrity is ready to design and build your monumental structures. Thank you very much for bringing that up. Thank you.